I welcome you to our series or videos. So this is another video on vectors. So in this video, we'll be discussing vectors. So the question reads, a vector A has components ax is equal to negative 5.00 meters and ay is equal to 9.00 meters. So the question continues, find A, the magnitude, B, the direction of the vector A. So this is what the question is requiring us to do. So we continue. So like I mentioned in another video, in physics, you are always advised to come up with a simplest possible diagram that is representing the question you've been given, or the simplest possible diagram showing how you've understood the question at hand. So this question, let's try to see how we are understanding it. So this is the diagram representing the question from the previous slide. So the x component is negative 5, so it's going to the negative sign. Then the y component, it's positive, so it's going in the positive direction. So we can tell that this vector is in the second quadrant. So what is the question requiring us to do? They want us to find the magnitude of the vector and also the angle. So what do we do? So let's continue. So to find the magnitude, this is the formula. A squared is equal to component y, a squared y plus a squared x. So these are just components of the vector. So when you simplify them mathematically, you come up with this. So meaning the magnitude of A or vector A is equal to the x component of vector A squared plus y component of vector A squared. So you square the components like I've shown here. So once you do that, you replace what was the x component of the vector. It was negative 5. So the negative 5, you square it. What was the y component of vector A? It's 9. So 9, you square it. What is negative 5 squared? It's 25. What is 9 squared? It's 81. So when you use your calculator, 25 plus 81, you get 106. So to find the magnitude of vector A, you have to find the square root of 106. So what is the square root of 106? It's 10.29563014. So the magnitude of vector A, when we write it to 3 significant figures, is 10.3 meters. So this is the magnitude of the vector. So we are done with the part A. So now let's look at finding the direction or the angle theta. So to find the angle theta, we use the formula theta is equal to tan inverse y over x. So this is the formula, and y over x, these are just components. Y is the y component of the vector, then x is the x component of the vector. So we substitute. Where there is y, we replace with 9 because this is the y component. from the diagram we saw. So the y component in the diagram, it was 9. Then the x component in the diagram, it was -5. But in this case, we can just ignore the negative. So when you simplify 9 over 5, you get 1.8. So now when you punch this on your calculator, so let's punch. So when we punch this on a calculator, we get the angle theta to be 60.945395.9. So this is what we get. So we write this into 3 significant figures. It becomes 60.9 degrees. So we know that this is not the final answer, because the vector here, it's in the second quadrant. So this is the first quadrant, second quadrant, third quadrant, fourth quadrant. So the vector is in this quadrant. So let's continue. So the vector is in the second quadrant. So what do? We are supposed to subtract 60.9 from 180. So when we subtract, we get 119.05. So when we write this into 4 significant figures, we are getting the theta to be 119.1 degrees. So this becomes the direction with respect to the positive x-axis. So always when you're dealing with vectors, you are advised to be using the positive axis as your reference point. So the magnitude of the vector, it's 10.3. The direction of the vector is 119.1 degrees with x-axis as the reference point. So thank you for watching. Remember to subscribe to our channel.